The Amazon River Basin represents the most complex, expansive, and critical reservoir of terrestrial biological diversity on our planet. Spanning over 6 million square kilometers, this immense neotropical realm dictates global weather patterns, regulates carbon, and houses roughly 10% of Earth's known species. Here, deep within the igapó, the seasonally flooded blackwater forests adjacent to the legendary Rio Negro, evolutionary adaptation reaches its absolute pinnacle. The high acidity and exceptionally low nutrient content of these tannic waters create a uniquely challenging environment, demanding extreme biological specialization from every resident. As the equatorial sun sets and the monsoon rains wash over the canopy, a profound ecological shift occurs. The nocturnal shift emerges from the shadows. In this lightless world, survival is dominated by acoustic communication, olfactory sensitivity, and absolute mastery over non-visual sensory processing. Consider the common Potoo, a nocturnal avian predator that relies entirely on cryptic coloration and morphological mimicry to evade detection during daylight hours. Its plumage mimics the textured surface of decaying bark so flawlessly that the bird effectively disappears into the timber, only opening its massive, light-gathering eyes under the cover of darkness. On the damp, decaying forest floor, gigantism is an effective and intimidating survival strategy, best exemplified by the Goliath Birdeater tarantula. Weighing up to 175 grams, this massive arachnid navigates the wet leaf litter using highly sensitive pedipalps to detect the micro-vibrations of unsuspecting prey. Lacking potent venom, it relies on sheer mechanical strength and the deployment of barbed, urticating hairs that it flicks from its abdomen to deter mammalian predators. High above the terrestrial predators, the Kinkajou, a procyanid relative of the raccoon, utilizes a fully prehensile tail and reversible hind feet to seamlessly traverse the dark canopy. Similarly agile but infinitely more lethal, the Amazonian giant centipede undulates across wet logs, employing its modified venom-injecting front legs, known as forcipules, to subdue vertebrates. Amphibians in this environment face constant physiological stress. The giant monkey frog combats sheer humidity variations by secreting a complex, lipid-rich wax from specialized cutaneous glands. Using its incredibly flexible hind legs, it meticulously spreads this waxy substance across its entire epidermis, creating an impermeable barrier that prevents fatal desiccation. Nearby, the night monkey, the only truly nocturnal simian in the world, relies on abnormally large eyes packed with light-sensitive rods to forage for fruit and nectar in the pitch black. Perhaps the most highly specialized nocturnal mammal is the common vampire bat, exhibiting remarkable terrestrial agility unlike any other chiropteran species. Utilizing elongated thumbs and powerfully folded wings, it stalks mammalian hosts across the jungle floor with a bounding, almost spider-like locomotion. Its saliva contains a highly potent anticoagulant glycoprotein, expertly named Draculin, which ensures that blood flows freely from a painless microscopic incision made by its razor-sharp incisors. The Brazilian wandering spider, renowned for its highly neurotoxic venom and intensely aggressive defensive displays, actively hunts through the understory rather than relying on the passive strategy of web building. Avian apex dominance at night unquestionably belongs to the spectacled owl. Its specialized primary flight feathers possess fringed edges that perfectly dampen aerodynamic noise. This evolutionary acoustic suppression allows it to execute perfectly silent flights, descending upon small mammals before they can register the shifting air currents. As the deep blue of pre-dawn approaches, the ocelot patrols the underbrush. A highly reflective layer behind its retina, the tapetum lucidum, maximizes its mesopic vision. Dawn in the igapó is heralded not just by light, but by thick, steaming mist rolling off the dark river, initiating the transition to the diurnal aquatic food web. The green anaconda, an aquatic, non-venomous constrictor of immense mass, utilizes the water's buoyancy to support its weight while thermoregulating in the early light. Beneath the surface, the Amazon River dolphin, or Potoo, navigates the submerged, tangled root systems using a highly sophisticated array of echolocation clicks. Unlike marine dolphins, the Potoo possesses unfused cervical vertebrae, granting it the extraordinary neck flexibility required to maneuver its bulbous melon through the flooded forest labyrinth. Giant otters, affectionately known as river wolves, form highly cohesive, remarkably vocal social units, utilizing a complex vocabulary of hums, growls, and warning snorts. These apex mustelids coordinate highly intelligent, cooperative pack hunting strategies to totally dominate the river's dense fish populations, displaying terrifying agility and speed. Red-bellied piranhas, often unfairly characterized as frenzied scavengers, are primarily opportunistic omnivores with a fascinating, highly specialized jaw morphology. Their interlocking razor-sharp triangular teeth are perfectly adapted for cleanly shearing flesh, acting in unison like a mechanical bear trap powered by immense jaw musculature. The electric eel, which is actually a species of neotropical knifefish rather than a true eel, represents a marvel of bioelectrogenesis. It generates high-voltage discharges, up to 860 volts, from specialized modified muscle cells called electrocytes, utilizing the current to stun prey and navigate the muddy benthic zones. Obligate air breathers like the colossal arapaima rely on a heavily vascularized swim bladder that acts as a rudimentary lung, a vital adaptation for surviving in hypoxic, oxygen-depleted waters. Furthermore, the arapaima's scales are heavily mineralized and arranged in a complex buligon structure, forming a flexible, bulletproof-like biological armor that protects against piranha bites. Conversely, the parasitic candiru relies entirely on microscopic size and near total translucence to survive. This hematophagus catfish swims upstream into the gill cavities of larger host fish. Once inside, it deploys backward-facing odontodes, sharp microscopic spines, to firmly anchor itself within the gills, parasitically engorging on the host's arterial blood. The mata-mata turtle exhibits absolute, flawless morphological mimicry. Resembling a decaying piece of sunken bark, it waits perfectly still for small fish to enter its strike zone. When triggered, it rapidly expands its neck and opens its mouth, executing a powerful, low-pressure vacuum strike that instantly sucks the prey into its cavernous jaws. Above the water, the neotropical cormorant perches with wings fully extended to dry its wettable plumage, a unique adaptation that drastically decreases its buoyancy. This deliberate waterlogging allows the cormorant to dive much deeper and swim with significantly less energetic expenditure while pursuing fast-moving aquatic prey. The silver arowana, often referred to as the water monkey, patrols the very surface tension of the river, utilizing its large, upward-facing eyes to calculate light refraction. With incredible explosive power, it launches its long, muscular body completely out of the water, snatching arboreal insects and even small birds directly off low-hanging branches. As the mid-morning sunlight finally penetrates the dense foliage, the awakening canopy erupts into a buzzing, chaotic, multi-layered symphony of acoustic and visual signals. The Hoatzin, a bizarre evolutionary anomaly, possesses an enlarged crop functioning much like a bovine rumen, utilizing foregut bacterial fermentation to digest toxic, rubbery canopy leaves. This unique, specialized digestive strategy makes them sluggish and clumsy flyers, emitting a distinct cow-like manure odor that deters many potential predators. Along the bright riverbanks, the Amazon kingfisher demonstrates incredible visual acuity, its specialized corneas compensating for the water's harsh glare and refractive index. With mathematical precision, it executes a perfectly calculated high-velocity dive, breaking the surface tension like a living dart to impale small fish. The brilliant, blinding iridescence of the blue morpho butterfly is not the result of pigmentation, but rather a phenomenon of structural coloration. Millions of microscopic, light-refracting photonic scales on the dorsal side of its wings interfere with light waves, bouncing incredibly saturated blue wavelengths back to the observer. On the dark forest floor, the dying poison dart frog displays fierce aposematism. Its vibrant neon coloration serves as a universal, highly visible warning of its extreme toxicity. These potent lipophilic alkaloid toxins are not synthesized internally by the frog, but are sequestered and highly concentrated from a specialized diet of toxic ants and alkaloid-rich mites. The bullet ant, possessing the most agonizing and highly rated hymenopteran sting on the Schmidt Pain Index, relies on a potent neurotoxic peptide called ponerotoxin. This venom violently overwhelms the central nervous systems of its victims, causing relentless, burning waves of pain that can incapacitate large mammals for up to 24 hours. In stark contrast to such solitary predators, leafcutter ants represent the absolute pinnacle of eusocial agriculture and complex collective engineering. Millions of highly specialized worker castes excise vast quantities of foliage not for direct consumption, but to utilize as an organic fertilizing substrate. They masticate the leaves to cultivate a mutualistic basidiomycete fungus deep within subterranean chambers, which serves as the sole nutritional source for the entire sprawling colony. Dominating the canopy's visual spectrum is the toko toucan. Its massive, pneumatized keratin bill acts not just as a feeding tool, but as a highly efficient thermal radiator. By flushing warm blood through the dense network of vessels within the beak, the toucan can rapidly dissipate body heat, a vital adaptation for surviving the oppressive equatorial temperatures. The undisputed apex avian predator of this biome is the harpy eagle. Females, significantly larger than males, can weigh over 9 kilograms and possess incredibly high wing-loading capabilities. They wield terrifying 5-inch bear-like talons capable of exerting hundreds of pounds of pressure per square inch, easily crushing the skulls of arboreal primates and sloths. Scarlet macaws display profound intelligence and complex lifelong social pair bonds. These vibrant frugivores engage in a fascinating behavioral adaptation known as geophagy. By congregating to consume specific mineral-rich riverbank clay, they effectively neutralize and bind the toxic secondary compounds and harsh alkaloids found within their unripe seed diet. The brown-throated three-toed sloth
relies on an entirely different survival mechanism: extreme metabolic depression. Its lethargic, energy-conserving pace radically reduces its caloric needs. Furthermore, its coarse outer fur contains specialized transverse cracks that host a symbiotic green algae, providing essential camouflage and a minor secondary source of lipid nutrition. As we descend back toward the understory, the southern tamandua showcases profound myrmecophagus adaptations. Powerfully muscled, digging claws and a long, viscous tongue. This prehensile-tailed anteater effortlessly tears into hardened arboreal termite nests, utilizing its sticky saliva to extract thousands of social insects without sustaining severe defensive bites. The South American tapir, the continent's largest native terrestrial herbivore, utilizes its highly flexible prehensile proboscis to efficiently strip foliage and fruits from low-hanging branches. Wallowing in deep anoxic mud is critically important for the tapir, serving dual purposes of immediate thermoregulation and the suffocation of embedded, blood-sucking ectoparasites. Emperor tamarins, instantly distinguished by their sweeping, majestic white facial hair, are highly agile and exceptionally communicative callitrichid primates. They form complex multi-male, multi-female groups, exhibiting fascinating cooperative polyandrous breeding strategies where multiple males actively participate in carrying and rearing the offspring. Common squirrel monkeys travel in massive, chaotic troops that can number in the hundreds. Their rapid, sweeping, and seemingly uncoordinated movements through the mid-canopy serve a distinct ecological purpose. This hyperactive foraging intentionally flushes out hidden, camouflaged insects from the foliage, creating a localized, highly mobile feeding frenzy that benefits the entire troop. The Venezuelan red howler monkey stakes its territorial claim not with physical violence, but with overwhelming, low-frequency acoustics that dominate the soundscape. An enormously enlarged, cavernous, bony hyoid apparatus in their throat acts as a biological resonating chamber, amplifying their guttural roar across kilometers of dense, sound-dampening jungle. Red-faced spider monkeys possess a highly specialized prehensile tail with a hairless, dermatoglyphic tactile pad at the very tip, enhancing friction and grip. This remarkable appendage functions flawlessly as a critical fifth limb, capable of supporting their entire body weight while their long, hook-like hands forage for ripe fruits. The Amazonian royal flycatcher spends the vast majority of its life looking unassuming and cryptic, blending perfectly into the dull brown twigs of the lower understory. Yet, when agitated or engaged in courtship, it deploys a spectacular, brilliantly colored crest, a sudden explosion of vibrant red and blue designed to shock and intimidate rivals or predators. Green iguanas, primarily folivorous reptiles, spend their days utilizing behavioral thermoregulation, basking high above the waterways on exposed, sunlit branches. If threatened by an aerial or arboreal predator, they exhibit an extraordinary, highly effective escape response, deliberately plummeting tens of meters directly into the river below to swim to safety. The emerald tree boa is an absolute paragon of arboreal ambush tactics. Deep labial heat-sensing pits line its upper and lower jaws. These incredibly sensitive infrared receptors allow this nocturnal constrictor to map out and strike endothermic, warm-blooded prey with deadly precision, even in complete pitch-black darkness. On the massive trunks of ancient kapok trees, the Hercules beetle relies on sheer mechanical leverage and thick, chitinous exoskeletal armor.
Males utilize their massive, sexually dimorphic thoracic horns, lined with gripping bristles, to grapple, lift, and physically throw competing males off the tree bark during intense mating disputes. The Guianan cock of the rock engages in some of the most complex lekking behaviors in the avian world. Males meticulously clear debris from small patches of the forest floor. Within these specific display courts, they perform intricate, highly aggressive hopping displays, snapping their wings to exhibit their flawless neon orange plumage to observing females. South American quaddies are highly social, diurnal, opportunistic foragers. Their packs relentlessly comb the forest floor, holding their ringed tails high as a visual focal point to maintain group cohesion. Their elongated, highly mobile rostrums are packed with dense olfactory receptors, allowing them to sniff out and uproot invertebrates buried deep in the soil or decaying logs. Collared peccaries navigate the dense underbrush in tight, well-defended herds. They possess specialized dorsal scent glands located on their lower backs. By vigorously rubbing their heads and flanks against one another, they effectively share scent profiles, a behavior used to mark territory and strongly reinforce their complex social bonds. The red-rumped agouti is a critical keystone species within the Amazonian ecology. Its immense jaw musculature and continuously growing razor-sharp incisors are evolutionary marvels. They are one of the very few animals capable of cracking the impossibly tough, woody exterior of the Brazil nut pod. By burying the surplus nuts for later consumption, they act as the tree's primary seed disperser. Near the muddy water's edge, the elusive bush dog operates in highly synchronized, cooperative family packs. These stocky, semi-aquatic canids have evolved partially webbed toes. This adaptation makes them incredibly persistent, lethal pursuit predators, capable of chasing terrestrial prey straight into the water and hunting them down in the shallows. The puma, highly adaptable and stealthy, fills the vital role of the secondary apex terrestrial predator. Its muscular, elongated hind legs grant it explosive, vertical leaping power. Moving silently on heavily padded paws, it utilizes its superior mesopic vision to ambush agile ungulates in the dense, heavily shadowed brush of the forest floor. The Amazonian horned frog is a true master of extreme terrestrial camouflage and patience. Its cryptic, flattened shape and fleshy supraorbital horns disguise its outline. By burying itself, it becomes entirely invisible within the dead leaf litter, waiting to unleash an incredibly rapid, gaping-mouthed strike that can engulf prey nearly its own size. Capybaras, the world's largest extant rodents, are perfectly evolved for an amphibious lifestyle. Their eyes, ears, and nostrils are positioned linearly along the dorsal top of their skulls. This specific anatomical alignment allows them to remain almost fully submerged in the water to escape them heat, while still constantly scanning the surrounding environment for threats. However, the seemingly calm, muddy banks of the Amazon hold ancient, hidden dangers. The black caiman is the undisputed apex predator of the neotropical waterways. Growing to lengths exceeding 4 meters, this massive crocodilian relies on highly sensitive integumentary sensory organs scattered across its dark, heavily armored scales. These specialized nodes can detect microscopic pressure changes and vibrations in the water, allowing the caiman to hunt effectively and track prey even in the murkiest, silt-filled, flooded forests. Yet, even the heavily armored, prehistoric leviathan of the river is not immune to the absolute, terrifying apex power of the Amazonian biome. The jaguar, Panthera onca, reigns supreme. It wields the highest bite quotient and the most powerful, bone-crushing bite force of any big cat on Earth. Unlike other feline predators that instinctively target the throat to suffocate their prey, the jaguar has evolved a uniquely brutal and highly effective killing methodology. Its heavily muscled jaws, powered by massive masseter muscles anchored to a prominent sagittal crest, drive thick, robust canines directly through the temporal bones of crocodilian skulls and the thick carapaces of turtles. In this brutal, breathtaking ecosystem, survival is a constant, unrelenting evolutionary arms race, a delicate balance maintained by extraordinary adaptations. It culminates in these sudden, awe-inspiring moments of explosive, kinetic power that ultimately dictate the enduring majesty and the raw, untamed reality of the Amazon rainforest. The Amazon River Basin stands as a testament to the raw, enduring power of evolution, a complex and fragile web of life where every niche is fiercely contested. It is a realm of profound darkness and blinding light, of agonizing venom and structural brilliance, of slow deliberation and explosive, lethal speed. To observe the Amazon is to witness the absolute limit of biological possibility, a testament to the resilience, the ingenuity, and the unyielding brutality of life on Earth.